Hi everyone, and welcome to Malfind Labs channel. I am Laskew, and in this video I would like to show you a second part of analysis of a password Bruteforcer that we found during an incident response engagement last year. In the first video, linked in the video description below and on the top of this movie, we analyzed a first stage dropper and obtained a second stage sampler. In this video, I will show you how to unpack and deobfuscate a .NET malware sampler protected with a ConfuserEx. As usual, I will link the sample in the video description below. Please stay with me, and I hope you will like this video. Last week we analyzed a piece of .NET malware that was designed to download and execute a second stage of the code. That kind of malware is called downloader. And additionally, it also had created a backdoor on the system. So it was a both backdoor and the downloader. Today we will see how to analyze this second stage binary. So as you remember, the first stage of malware downloaded this dzip file from the Iranian domain. I have it here already. I unpack it. And let's see what it is. We use exeinfo.pe as in our last video. And we see again it's a .NET 64-bit executable. So we can use our already well-known tool, which is dnspy, to analyze it. And when we put our binary there and we go to the entry point, we already see it won't be that easy because the stuff we see here is basically garbage. There are some methods, but they are like the names are unreadable and some parts of the code are even not decompiled correctly. So it would be really hard to analyze this in that state. So if we go here, we actually see this kind of a signature confused by Confuser Core 1.3.1, and that basically means, if you want to Google it, that this binary was packed and obfuscated by ConfuserEx. That is a tool, open source tool that was quite popular, especially in the past, to protect .NET binaries from the eye of the people who wanted to basically see what's inside. Not only malware used this, also legitimate applications that wanted to protect their digital rights and stuff like this. So what this software does is basically speaking, packing the malware. So the entire idea of packing is to take a binary that we want to execute on the system and encrypt it or pack it or zip it, pack it with some compression mechanism, so it's not that easily readable anymore, and put it in another binary that serves as a wrapper. And basically the entire purpose of this binary is to unpack and execute the original binary. So either decrypt it and execute it, or unpack it and execute it. And ConfuserEx is basically a packer, but it also has some more capabilities like anti-debugging and anti-tamper and renaming of the methods, so obfuscation and things like that. So I will show you first how to defeat it, because we need to defeat it first to analyze our binary, and then we will proceed to analyze the code of the malware itself. How would we approach deobfuscating and unpacking this malware then? Well, let me tell you first about the static constructor. So remember when I told you that entry point is the first part of the code that gets executed, and that there are exceptions to this. So this is one of them. So we have something that's called cctor, module cctor. And when we go to it, we are in the static module constructor. And constructor in objective languages is the part of the code that got executed when some class object is being created. And because everything is an object in C#, the program itself is also kind of an object. So when the program gets created first time in that thread, the static constructor got executed before the entry point. And people who created ConfuserEx and some other packers know about this, so they abuse it. And they put in here the code that will modify our binary before the entry point gets executed. So we cannot really see the code in the binary itself before the static constructor, the CCTOR, gets executed. And what's being done here, it's actually a few things. So I won't deep dive into how ConfuserEx works because this is beyond this video and there are quite good write-ups already about this that I will link in the description below. So feel free to read them. I will only briefly tell you about Anti-Tamper. So the Anti-Tamper is actually the first method that got executed in here. And you can easily recognize it by this Marshall get age instance call, and also by the fact that it has this long switch with some arithmetic instructions and this call to the virtual protect somewhere there. So what the Anti-Tamper does, it's changing the values of the methods array table. So if we go to the tables in here, we need to go to the methods. There's something like a relative virtual address for every method that's being called in the system, in the program, sorry. And when this is modified, obviously the program cannot be executed. So what the packer does in here is encrypt these values with a simple XOR encryption. So we cannot really execute this code without decrypting these values first. And Anti-Tamper basically decrypts these values and returns them to the previous state, and then it loads the correct module into the memory. So how would we defeat this Anti-Tamper? So first of all, let's go back to the CCTOR. And this is our Anti-Tamper routine. So as I described what it does, it just basically decrypts this RVA table in memory. So it basically makes some changes to the binary in the memory. So we need these changes to be made. And then we need to dump a modified binary from the memory. So what I'm doing is I basically put a breakpoint after the Anti-Tamper and let it run, let it make its changes, and then we will dump a modified version of the binary from the memory, the one with the decrypted table. So let's just run it. As we can see, it stopped after this first routine has been run, and then we can simply go to the window modules, save this to the disk. We can call it whatever, just Windows Desktop Service Tamp. We can already stop this one and remove it. Then we get a new one to the NSPY. We go to the CCTOR again, and now, because this is the version with already decrypted RVA table, so we don't want this function to run again. We don't want it to make these changes again, because it's assumed it's decrypting it when it actually isn't, so it will probably just end up in the exception. And I can show you this. If we simply run it, yeah, it will just run into the exception. So what we want to do is we want to remove this call, and to remove it from the from here, we need to go to edit ER instructions. Simply replace it, right click or just press R, replace it with nopes, with nope instructions, and that will simply just get removed from the code. One thing to remember, something I always keep forgetting when using dnspy, is if you made this modification, it doesn't really reflect yet in the way this binary behaves. So if I run it here again, it will run into the exception again, because it simply runs the version of the binary that is in the disk, so, and not the modified version, let's say. So what we need to do is to save it again, save it as no tamp, or nope even was good. So the tamp anti-tamper function is not. We can remove this, get this one, go to cctor again. We can see there's no anti-tamper function anymore. So what we want to find right now is something called gc handler .free. So we actually have two of these, I think, in this version. We put the breakpoint of both of them, but we actually are interested in this one. So what it does is simply, with the anti-tamper removed, the binary is now unpacking. So what I told you earlier, it's unpacking the original binary from the memory, from the pack version to the unpack version into the memory, and then it will run it. So why we put this breakpoint on this free routine is basically releasing the memory after the unpacking is done. So if we know all the unpacking functions have been done, because it's releasing the memory. So let's run it, and yeah, it will break here. That's great. And if we go here, we can see this module COI. This module COI is actually something that's really related to how the ConfuserEx working internally, but that's basically our unpacked binary. And we can simply save it here. And once we save it, we can stop this. We can remove it from here. So our COI binary is already the unpacked binary, but there's still few things we need to do with this. So it actually also has the anti-tamper. So we basically need to repeat our actions from the previous binary. So first we shall set the breakpoint after the anti-tamper. We run it. We save our module. We stop this, remove this. Then we need to remove the anti-tamper. Replace it with nopes. Save the binary. Yes, I want to save it as a nope tamp. And then it actually should be already deobfuscated. the last thing we want to do is to make it a little bit more readable. So you can see this kind of function calls are not really like user friendly. So and the other names as well. So what we want to do here is to actually get this last version we have and use the tool that's called D4dot on this one, and it gave us the version that it's called cleaned. And if we load it in here, you can see that the methods has been renamed. So still doesn't tell us much about what they do, but at least they are a little bit more human friendly, and as a follow-up we can analyze the functions and rename it up to our own convenience to give us more information, and we will also do that. But at least the naming is a little bit human friendly, like class 1, class 2, class 3, attribute 0, 1, 2, method 10, method 4, method 2, etc., and not some just random garbage. There's one more thing we want to do in here, and it's finding the entry point. So if we right click in here, you can see there's no option to go to the entry point, like in here, for example. So that's because there's basically no entry point in this binary right now, because we dropped it from the memory, and the way we dropped it just doesn't conserve that information. So what we want to do in here is, there's two ways basically, either to look at the packer or to look at the code and try to make an educated guess which function is the main function. The method I show you today is how to make an educated guess. And it's actually quite simple. If we look at the Microsoft documentation about the C#, you can see the main method is usually of the type void, and it takes as an input the array of strings as an argument. So usually that's the method we will be looking for, and there's easy way to find it in dnspy. So it will be usually the first method to be invoked in the code, as we already said. So I will just take some random method. Let's say, for example, socket method. You can see it's used probably in the code to make some kind of communication. So it's a good candidate to be called at some point from the main function. So we want to use the analyzer in the dnspy and see what this by what method is this socket method called. We can see it's called by two different methods. So we just go like this and go deeper. So this method is actually called by this method, and this method is called by method 0, and the method 0 is called by method 84, and the method 84 is not called by anything. So it's basically the first method in all this execution chain of methods. So let's see if it's viable candidate to be a main function. It actually is, because it's of type void and it takes an array of string as an argument. So exactly what we saw in here. And because it's a first method that it's called, and it's not called by any other method, it's a very good assumption to do that it's probably our main method. So let's take a look at here. and what it does, and we can clearly see it. It does something with the show window method, probably hides the window at the beginning, and then basically spawns 3 threads. So I would say based on this, very likely it's a main method. Let's rename it and call it main. And now we can actually edit this module and say this is our entry point. And after we do this and save our module, we should be able to actually run it and debug it and analyze it. And I will show you how to analyze it and see what it does in the next video. This is all for this part of the video. I hope you understand now how to defeat simple protections in .NET code, unpack and deobfuscate the sample. In the next video, I will show you how to analyze this deobfuscated sample to understand more about its functionalities. If you enjoyed this video, please leave a like and subscribe, and if you have any comments or questions, leave a comment below. Until the next time.